you have a quadratic trinomial. What's weird about it?
It's in fractions.
Fractions, a bunch of fractions, right? Now notice that all the fractions have a denominator of 3. So to make it a little more understandable, I want to factor out the a value. I'm going to factor out a negative 1/3. If you factor out a negative 1/3, bless you, what are we going to have left? We're going to have x squared plus negative 4x and then minus 5. So I guess I shouldn't have put the plus in there. Let me erase it. But that's what you get when you factor out a negative 1/3. If you take a look at the inside of the parentheses, you have a quadratic trinomial that is factorable, right? You do the two sets of parentheses, x, and you think what times what is your last number, which is negative 5, that if you combine together gives you negative 4. So what will that be? A negative 5 and a positive 1. Now don't forget to bring down your negative 1/3, which is technically your a value on your intercept form equation. Some students ask, do I need to change this to a g of x? You did not change the parabola at all. All you did was change the equation. So it has to stay f of x. If you put g of x, technically I have to mark something wrong, okay? Now, you only put a g of x, bless you, when you transform. You only put g of x when you transform the equation, like a vertical stretch or a compression or a translation. Then yeah, you change it because you're actually changing the physical aspects of the parabola. But right here, all you're doing is rewriting it in a different form. If you were to graph this on a calculator, it'd give you the same exact parabola that's opening down, that's kind of wide, as this intercept one that's opening down kind of wide. Same exact parabola. Bless you again. Allergies, killing you. Okay. So on number 11, let's jump to number 11. We have that function right there. They want us to rewrite that standard form in intercept form, and it is as simple as factoring. What times what is 5, that if you add together 6, that'll be a positive 5 times a positive 1. That's 5, and if you add it together, it is 6. There's your f of x function. You didn't change it at all. You just changed the way it looks. So that's your answer to rewriting it in intercept form. Actually, no, they say state the x-intercepts. So we need to state the x-intercepts, and the x-intercepts will be x equals 5, and x equals negative 5, and x equals negative 1. Those are your x-intercept values. That's your answer. Once again, when it's in intercept form, you could see your p and q value. Your p and q value are right there. All you have to do is think opposite. What about the axis of symmetry? Well, there's different ways of doing the axis of symmetry. You could find your axis of symmetry by adding the p and the q together, then dividing by 2. But it's actually negative 5 plus negative 1. So if we did that on the side, negative 5 plus negative 1 divided by 2, that will give you what as an answer? X equals negative 3. And that is your axis of symmetry for this equation up here. Now let's say you get totally blanked out. You forget how to find the axis of symmetry when it's in intercept form. You could always go back to x equals negative b over 2a. So you could also go negative b over 2 times a, and that'll still give you the same exact value as the negative 3. Jumping to number 14. That one's really simple. So simple you might get confused because it gives you the zeros, negative 3 and 4. What are zeros? X-intercepts, right? So they're really giving you the x-intercept values of negative 3 and 4. What are x-intercept values? Well, if you think about intercept form, they are your p value and your q value. Isn't that right? So I'm just writing down things that we need to know by now. That zeros are x-intercepts, and what are x-intercepts p and q if they're in intercept form? So let's write down the intercept form equation, or let's write down any intercept form equation that has p and q as negative 3 and 4. So I want to write down y equals parenthesis x minus p, which is going to be a minus 3 since negative 3 is p, and then times x minus q, and q is 4, so I'm going to put x minus 4. So the minus has to change to plus plus. Is everybody with me? Ladies and gentlemen, that is an equation that has the zeros of negative 3 and positive 4. And now we need to change to standard form. So what do? You just distribute x times x, x squared, x times negative 4, negative 4x, 3 times x, positive 3x, 3 times negative 4, negative 12. And you combine the middle terms, you'll get your x squared minus 1x, or just minus x minus 12. And ladies and gentlemen, that is an equation in standard form that does have the zeros of negative 3 and positive 4. Number 7, you have a function and it's an intercept form and you want to rewrite it in standard form. Rewriting in standard form is cake. All you have to do is simplify. So what I like to do is focus in on the parentheses first. So I like to go x times x and get x squared, x times 2 and get 2x, negative 3 times x, get negative 3x, and negative 3 times positive 2, that's negative 6. And then I combine like terms, x squared minus 1x minus 6. That's my new standard form quadratic trinomial, but I still have the negative 1/2 that I need to have out here in the front. So I still need to distribute that in order to be done with my standard form quadratic trinomial. So negative 1/2 times x, negative 1/2 times negative 1, negative 1/2 times negative 6. You're going to get your new quadratic trinomial equation that says f of x equals negative 1/2 x squared plus 1/2 x, and last but not least, plus 3. And we are done. So if we jump to number 10, we have another intercept form equation, and it says state the x-intercepts. So if it's an intercept form, why do they call it intercept form? Because it tells us the x-intercepts, right? And what are the x-intercepts? It's p and q, right? All you got to do is think opposite of what you see here and what you see here. So your p value happens to be negative 2. Your q value happens to be positive 4. So what are your x-intercept values? You could just write x-int and then say equals, or you could say x equals negative 2 and 4. Those are your answers for that one, negative 2 and 4. Now it also asks you for your axis of symmetry equation, right? Now remember, if you're talking about, let me draw a little diagram here. If you're talking about your x-intercepts being at negative 2 and at positive 1, 2, 3, 4, you're talking about having a dot there and a dot here. Now you don't have to graph it. I just want to give you a visual of what I'm about to do. So where's your axis of symmetry at? It's going to be perfectly in the middle, right, of the two dots, because there's symmetry on parabolas. So if it does cross right here and right here, then your axis of symmetry has to be perfectly in the middle. Now you don't want to actually draw it and count where's the middle. The easiest thing to do is to simply add your two x-intercept values, add the negative 2 and the 4, and then divide by 2, right? So if you do the work p plus q divided by 2, that'll give you your axis of symmetry, which would be your x equals equation. So what is 4 plus negative 2, or negative 2 plus 4 divided by 2? What is that? Anybody? Nobody knows how to do that? 1. Okay, so my axis of symmetry will be x equals 1. There's that answer. Simply add p and q together, then divide by 2.